Okay, here's video number 2. Just wanted to explain again how the comparator circuit was working. Still have the same settings from the last video. I'm sitting at about 97.7 millivolts from my input signal. Now, here's my comparator circuit. I have two 5.1 kilo ohm resistors. Okay, set up as a voltage division. And if you recall from the very first lab, if you have two resistors with the same value, you should be reading half the source voltage. So I should be reading about 6 volts on pin number 2. Let's look at the schematic real quickly. Pin number 2 is what the division is of the circuit. Okay, taking the reading from output, pin number 6. And I'm varying in V3, which is the voltage supply that's adjustable. In my case, it's the very top supply here is the adjustable voltage. Now, what should happen ideally with the comparator circuit is the threshold is set now at 6 volts. There is 6 volts on pin number 2 for the input of the comparator. Now, if you look at our diagram we have here, what we expect to happen before 6 volts is to have the negative rail of the power supply, and then after 6 volts we should have the positive rail of the power supply. Let's see if that holds true. Again, currently I'm at 97.7 millivolts. So let's go ahead and increase. I'll try to keep the camera on both at the same time. So as long as I'm below the 5 volt range, you should not see a change. But as soon as I hit 6 volts here, let's go ahead and hit 6 volts. Now look, right at 6 volts, I go above the threshold. Now watch this. Right below the threshold, I am at minus 9.8 volts. Right above the threshold, I'm at 11.4 volts. So that's the general concept of the comparator circuit. Video number 3 will be the decade box, the one that most people had the problem with. Stay tuned for video number 3.